So today we're going to look at regular polygons, and specifically we want to take a look at the interior angles of regular polygons. So here we have a creepy looking pentagon here that has 5 congruent sides and 5 congruent angles. Remember, a regular polygon, regular, has congruent sides and angles. So this is a regular pentagon. We want to look at the interior angles. So to find the interior angle sum, what we want to do is break this into shapes that we know the angle sum for. And we know the angle sum for a triangle is 180 degrees. So what I'm going to do is I'm going to divide this pentagon into as many triangles as I can. But here's the catch. We want to pick one vertex and only one vertex and connect it to the opposite vertices that we can without crossing any diagonals. So here's how it's going to work. So how many triangles do we have? We have 3. And what I mean by not crossing is we don't want to, say, connect this vertex to this vertex. Okay? Because that's going to cause an intersection here somewhere in the center of the pentagon. And when you create intersections of lines, you're creating more angles. And that's just going to cause us confusion. So we don't want any of these diagonals to intersect. That's why we pick just one vertex and connect all the ones we can. We'll be fine. So we have 3 triangles. And what's the angle sum for each? 180 degrees. So that's pretty easy to solve, right? We can simply just add up the 180 degrees 3 times, and that's our answer. So that's the angle sum. So in general, when you have a polygon, the angle sum is going to be n minus 2, where n is the number of sides. So here in this example we had 5 sides, and you multiply that by 180 degrees. And the reason for that is it's just basically saying how many triangles can you divide it into. And in this case it was 3. So n in this case was 5 minus 2 would be 3 times 180. This actually works for any polygon, not just regular polygons. Now if we do have a regular polygon, we can actually find what each individual angle is because they're all congruent, right? So in this case we would just have to divide it by the number of angles that we have. And the number of angles of a polygon is simply the number of vertices, right? So we have 5 interior angles. So each interior angle of a regular polygon is n minus 2 times 180 degrees divided by n, which is the number of sides. So let's take a look at this specific example, which is the regular pentagon. So we had 5 sides minus 2 times 180 divided by 5. So that's 3 times 180 degrees divided by 5, which is 540 degrees divided by 5, which is 108 degrees. So that's just saying each one of these interior angles is 108 degrees. So now let's take a look at exterior angles. So we have our creepy pentagon again, and we know its interior angle. So each of the 5 interior angles are 108 degrees. We just solved that problem. So what's the exterior angle going to be? The one on the outside. And so to draw an exterior angle, remember you just have to extend this one side. So that's all I did here. I extended this side and it created an exterior angle. So we have this linear pair of angles, which are supplementary angles. So if I know their supplements, I can simply say that's 180 degrees minus 108 equals 72 degrees. So how many exterior angles do we have? We have 5. 1, 2, 3, 4, and 5. So 5 times 72 equals 360 degrees. This actually works for every polygon. So if we create the exterior angles for a polygon, and it creates this kind of little water wheel type shape, right? If you picture a water wheel, you know, that kind of spins the wheel around, and it goes around in a circle. So all of the exterior angles add up to 360 degrees. This is a fact that is really, really useful in solving problems, especially when you have a regular polygon. Because if you know the exterior angle is 72 degrees, it makes it very easy to solve the interior angle. Because all of the exterior angle sums are going to be 360 degrees. Think of that wheel again. So 360 degrees, each exterior angle is simply 360 degrees divided by the number of sides. And this works for a regular polygon. Now that we know the exterior angle is 72, we can work backwards and find the interior angle, which is 108. So this is a lot easier than using and even memorizing that other formula or dividing the shape into triangles like we did in the previous example. Because if you know the exterior angle sum is 360, you can find each one is 72, and then just use the fact about supplementary angles, and you know it's 108. So that's all I have for you now. Please let me know if you have any questions.